even though every student in this class has seen acid-base chemistry before, the vast majority of you have also seen some heuristics and some misconceptions which unfortunately have lasted up until now. I personally had the same experiences when I was in high school and when I got to college, and it was kind of a shock to understand that pH wasn't what I thought it was, and neither was something like neutral. So this would be a lot more fun if I got to be in lecture and I could see your faces when I said this, but let's try it anyways. Here's a beaker. It's a beaker full of water. You have to imagine. Remember, this is Sunday night. We're all tired. There's a lot of snow. Good imaginations, people. Okay? Here's some pure water. Nothing else in this water whatsoever. 37 Celsius. Body temperature. The pH of this water is 6.8. Now, right away you're thinking to yourself, the reason why it's 6.8 is because the probe doesn't work. Well, you're right. pH probes are not good at around pH 7 or pH 8 or pH, right? pH probes use ions to measure the conductivity of solution. At pH 7, there's the fewest number of ions that you could expect to have in solution, so you're right, the probe doesn't work well. But that's not why it says pH 8. It's not a broken probe. So then you're thinking, okay, there's contamination. Well, but if that's the case, then I lied to you earlier when I said it was pure water and nothing but pure water. So given that I'm not lying to you, it's not contamination either. So I now need you to really understand and to be with me that the pH of this water is 6.8. At which point I ask you, is it acidic, neutral, or basic? So I'll give you a few seconds to think about it. By now you've all probably said acidic, and this is when I tell you that in fact it's neutral. And the reason it's neutral is not because of its pH. So this is where we have to start thinking about what pH really means. pH is the negative log of the hydronium ion concentration. pKa is the negative log of Ka. pKb is the negative log of Kb. pKw is the negative log of Kw. And P. Wee Herman is a convicted felon. Okay, terrible joke. Px is negative log x. Hopefully you can see that P is the chemist's shorthand for the mathematical function negative log. If that's the case, we have to stop attributing meaning to pH and understand that it's just telling us something about the solution. So what's this telling us? What it's telling us is that in this solution, this one over here, where I said I just put pure water, there's actually some hydronium ions, which really shouldn't surprise anybody. How much hydronium ions? Well, that's right, 10 to the minus 6.8 moles per liter. Now, this is where we get a little bit up in arms. We say, but wait a minute, you said it was deionized water. If it was deionized, that means it has no ions. But hydronium is an ion. Well, sorry to say, deionized water has ions in it. It doesn't have many ions, but it does have ions. One of the ions it has is hydronium. How does it get the hydronium? Exactly, the autoionization of water. So water reacts with itself and makes hydronium ion and hydroxide. So if I were to follow up with a question, are there any other ions in this solution, you'd probably say, yeah, there's got to be hydroxide. In fact, that there is. And how much hydroxide is there? 10 to the minus 6.8 molar. Because for every one hydronium that forms, one hydroxide must also form. This is just an ice table kind of thing. So, is this neutral, acidic, or basic? I said it's neutral, and the reason I said it's neutral is because of this. Because the amount of hydronium, which is the acidic species, and the amount of hydroxide, that's the basic species, are equal. So when is a solution acidic? When the hydronium ion concentration is greater than the hydroxide ion concentration. And when is it basic? When the hydronium ion concentration is less than the hydroxide ion concentration. And again, this just means when the pH is less than the pOH, or when the pH is greater than the pOH, because P is just a mathematical function. So I remember, and it was a long time ago, but I remember at this point in the lecture, I'm thinking to myself, well, what else did they lie to me about? I bet pH isn't even a scale. And the answer is no, it isn't. So I remember in high school, I remember seeing this scale. So 14 and a 0 and a 7 and a big neutral sign here. It's vivid. I think this was blue. This one up here was red. Maybe the colors are backwards, but you guys get the idea. So there was a scale from 0 to 7 was acidic, from 7 to 14 was basic, and 7 in the middle was neutral. So we've already said that this 7 being neutral, that's only at 25 Celsius. At 37 Celsius, neutral's lower, and at 10 Celsius, it's going to be higher. What else was a lie? Well, if we were in the lecture hall and we had a stockroom right down the hall, I would invite you to follow me down to the stockroom where we have 18 molar hydrochloric acid. Hydrochloric acid is a strong acid. And strong acid means reacts 100%. 100% with what? With water. So HCl reacts with water to make hydronium and chloride ion. Now, you might stop me and say, hey, nothing reacts 100%. You're right. 99.9999. If I were to start with 1 molar HCl, I would have 10 to the minus 7 molar HCl left by the time the reaction were done. So if that's the case, if I have 18 molar HCl, how much hydronium do I get? Yep, 18 molar. So what's the pH? If I were to stick a pH probe to my 18 molar HCl, negative log of 18, I would get negative 1.3. Yep, lower than 0. And I'm sure that you could imagine if I took 15 molar sodamide, I would get a pH that's greater than 14. So this was a wonderful thing for us back in the past, but it's time to scrap notions of scales and really understand that these are equilibria, and understanding how to manipulate these equilibria, the strength of these equilibria, will explain to us amazing things like how materials work, how proteins fold, and more. So stay tuned for the next lecture where we're going to delve into these things in greater detail. I wish I could have seen you guys in person. Hopefully this will suffice. Have a wonderful day. Stay dry.